Okay, this is a Unit 2 review for MAT171, and we're going to start with we're going to write the partial fraction decomposition of the given rational expression. And let's say that we have here a function such as 6 over x squared minus 3x. Okay, the first thing we want to do here is we want to go ahead and factor this denominator. So this would be 6 over, and then we want to factor out the common factor, which would be what? Should have said x. So this would be x times x minus 3. And now we want to write the two parts of our partial fraction decomposition. So you take each denominator, and so this will be a over x, each factor in the denominator, plus b over x minus 3. And then we want to, the easiest way to do this is to look at each denominator, set each denominator equal to 0 and solve. So we get x equals 0 and x minus 3 equal to 0. And so we would solve this x minus 3 and we get x equals to 3. So the purpose of this is we want to eliminate either the a or the b, or both. Since there's only two, we want to eliminate just either the a or the b. So the first thing we're going to do here is we need to multiply out the denominator. And it's easier to go ahead and multiply it out when it's factored out. And so we would multiply out this denominator. Here we'd multiply x times x minus, actually let's do this on the right, x times x minus 3, x times x minus 3, and x times x minus 3. So here the x times x minus 3, those all cancel out, and so we just get 6 on the left side. And here the x's cancel out, and so we get a parentheses x minus 3 plus, and here the x minus 3's cancel, and we get bx. So now we want to take one of these two factors of the denominator and go ahead and start substituting them in to eliminate either the a or the b. So we'll start with x equals 0. So we substitute 0 in wherever there's x. So this would be a parentheses 0 minus 3 plus b times 0. Well, b times 0, that just goes to 0. So that just leaves us with 6 equals to a times the negative 3, or you could say negative 3a. And so now what we want to do is isolate the a, so we divide both sides by negative 3, and we get a equals to a negative 2. Alright, so now we have a, but we need to find b. So we can use the other factor for the denominator, x equals to 3. And so we plug that in. And so here we have 6 equals to, and we know that a is negative 2, so we can just substitute that in. We're going to put 3 minus 3 in here for x plus b times 3. Well, here this cancels out. This negative 2, 3 minus 3, that'll be 0. Negative 2 times 0 plus 3b. Alright, so now we can isolate the b, and we divide both sides by 3. Divide by 3, divide by 3, and we get b equals to 2. So our answer from up here, 6 times x squared minus 3x equals to, we said a is negative 2 over x plus 2 over x minus 3, and that's our answer. That's all you have to do for that. Okay. Let's say that we have, next let's take a look at piecewise-defined functions. First, we'll look at substituting some values in, such as, so this first one, we'll call that problem 1. The second one, we'll call that problem 2. And we have here h of x equals to a negative 2x minus 3 for, now you could say if or for, it really doesn't matter, x is less than, let's say, negative 2. And then we have here, let's say, 3 for x is greater than negative 2 but less than positive 3. And the third one, we'll say x plus 5 for, this should be greater than or equal to negative 2 here. So this would be for x is greater than or equal to 3. And let's say we want to find h of a negative 8, let's say. Well, first thing you have to do is look for each one of the 3 of these. Since negative 8 is less than negative 2, you would use the first function. So this would be negative 2 times negative 8 minus 3. So negative 2 times negative 8, that would be positive 16 minus 3, and we get 13 out. Alright, now let's say that we want to find h at negative 1. Well, we want to see where does x at negative 1 fall in? Is it less than? Is it greater than or equal to negative 2 but less than 3? Or is it greater than 3? And you should have said the middle one. Negative 1 is greater than negative 2 but less than 3. So therefore, since there's no value for x to put in here, there can only be one answer, 3. So if you were to look graphically, here's 3. This would be negative 1, 3. So no matter what value you have from negative 2 to less than 3, your answer out is going to be 3. Alright, and then for h is, let's say, 3. So you're saying, okay, which one of these 3 would you use given x is at 3? Well, here x is greater than or equal to 3, so you would use the third one. You can say use values that are greater than 3 or equivalent to 3. So you would put in here 3 plus 5. You would use the third equation, and we get 8 out. All right. And that's basically, there's more, but we're just basically, those are the three that covers all three of these parts of the piecewise defined function. Alright, now let's take a look at a piecewise defined function, but we want to graph it. And here we have f of x is equal to, and we want to say x minus 2, 4. X is less than or equal to 0. And we'll say 1, 4. X is greater than 0, but less than or equal to, let's say, 3. And 1/3, 4, x is greater than 3. Now, when you're, oops, x should be x here. X is greater than 3. Alright. So, you want to, for graphing, you want to split it into three functions, such as f of x is equal to x minus 2, 4, x is less than or equal to 0. Alright, that's the first one. And then here we have f of x equals to 1. 4, x is greater than 0, but less than or equal to 3. And then the third one is f of x is equal to, this should be 1/3 x here. 1/3 x. 4, x is greater than 3. Okay, so basically, if you're looking at the graph, what you have here is at 0, that's covered by this f of x equals to x minus 2. And so that's including 0 and less than that. Here in the middle, and then you've got 3. You've got your function f of x is equal to 1. And that should be x here. And that's going to be in between, where it's going to be open here. It's going to be open but closed. I don't want to use an arrow, but closed on the other end. So it's going to be somewhere in between here. And then the third part, f of x equals to 1/3 x, that will be greater than 3. So we want to use our table of values. And so we want to start with our restrictions. 0, and since it's going less than 0, it'd be -1, -2, and that should be enough. So so we put in 0 here and we get -2 out. At -1, -1 and -2, we get -3 out. And -2, -2 and -2, we get -4 out. So on our graph, we say we look at a restriction, and that at 0, x is less than or equal to 0, so that's closed. So that'll be a closed dot at 0. And so we're going 0, -2, and that's closed. And we'll use red for that. And then -1, -3, and then -2, -4. So we get, and because it's less than 0 and there's nothing restricting beyond that, you get an arrow. Okay, now let's look at the next one, f of 1. So here's our table of values for f of 1. And so we start with 0 again, but because x is greater than that, it's open. And we go 1, 2, 3. So no matter what x is, y is always going to be what? Y is always going to be 1. So this will be 1, 1, 1, 1. And so it's open at 0, but what do you think is going to happen at 3? Is it going to be open or closed? You should have said it's going to be closed because x is less than or equal to. So that's closed. Okay, so we have here x is 0, y is 1. So that's open. X is 1, y is 1. X is 2, y is 1. X is 3, y is 1. And that's closed. So notice there's always going to be 2 points. One's open, one's closed. Here, this is closed, so guess what? The other one is going to be, in this case, is going to be open because x is greater than 3. So let's look at this function. And so for f of x is 1/3 x, we put in our table of values, and what do we start with? Because the restriction is at 3, we start at 3. And that's open. And because x is greater than that, we're going to go 3, 4, 5. And now, since 3 is the denominator, it's easier if you use multiples of whatever your denominator is, like 3, 6, 9. So that will evenly divide into the denominator, like 1/3 times 3, we get 1 out. So that's 3, 1. 1/3 times 6, 3 goes into 6, and that's 2 out. And 1/3 times 9, we get 3 out. Okay, so that's because it's greater than, it keeps going, that's going to have an arrow to it as well. So that'll be 3, 1. So that'll be 3, 1, and that's open, and so that's going to be an open circle right there at the same point, 3, 1. And then 6, 3, 4, 5, 6, 2. 6, 2, and then 9, 3 will be out here. So you get that. Now, you may not, because I made this up off the top of my head, you most likely will not see one point on top of another one like that. It'll be up higher, down below. So just keep that in mind. Alright, but this is what your piecewise defined function looks like. Okay. Let's try another one. Here we have f of x. Actually, let's go on to the next side here. I don't want to run out of room. Here we have f of x is equal to x plus, or minus, let's say x minus 3 over x plus 2. And when we want to know, first question is the point 3, 4 on the graph. So the 3, that would be your x. The 4, that would be your y. So we would put 4 in here, or we could also say x and f of x as well. So the 4 will go in for f of x, and the 3, that'll go in for x, so that'll be 3 minus 3, and then here we'll put 3 again in, plus 2, and 4 equals to 0 over 5, or 4 equals to 0. So in order for this to be a yes, both sides would have to equal. Since both sides don't equal, the answer is a no. Alright, and let's see, this was question, I believe, question 3. 2. This is 3, so this is question 4. Alright, next thing is, and we'll call this part A instead of 1. Part B, if x equals to 4, what is f of x? Alright, well here what we have to do is we have to substitute in. So we're going to put in here f of 4 is equal to, and we're going to put 4 in for x. 4 minus 3 over 4 plus 2. And so we get out 4 minus 3 is 1, 4 plus 2 is 6. And it also asks what point is on the graph. In other words, since x is 4 and your f of x, you're looking at x and f of x. Since x was 4 in, f of x is 1 over 6 out. So your answer is 4 comma 1 over 6. Okay. Alright. Part C. If f of x is equal to 2, what is x? So now for our function f of x equals to x minus 3 over x plus 2, we put the 2 in the f of x side. So this is 2 equals to x minus 3 over x plus 2, and then we solve. So we would have to multiply both sides times x plus 2, multiply x plus 2 times x plus 2, and then distribute the 2 here. So that'll be 2x plus 4 equals to x minus 3, and these two denominators cancel out. Alright, so now this is just a linear equation. I like to go ahead and combine the x's first to keep them positive. And so we get x plus 4 equals to a minus 3 or a negative 3. Apply minus 4. Minus 4. We get x equals to a negative 7. And always a good idea to check your work as you do this. Alright, so we want to know what point or points are on the graph of f. So this is still part of part C. What point or points is or are on graph f? Well, you tell me. You're looking at x and f of x again, right? Well, what was x? You should have said x is a negative 7. And what is f of x? Well, f of x, that's what we started with. We substituted that in. F of x is 2. And so that is our answer for that part of the question. Okay. Part D. What is the domain? Well, we look here and we said there were two ways that domain would not be negative infinity to infinity. What were those two ways? Pause the video and try to remember them. Okay. The first one is if x was in the radical. The second one is if x is in the denominator. So which would this one be? In this case, we have x in the denominator. So what do we do to find where we have a restriction in our domain? We would set the denominator equal to 0, right? And then solve. So we would take that x plus 2, set it equals 0, and then solve. And so we apply minus 2 and get x cannot be a negative 2. Because if we put a negative 2 in here, right, you got negative 2 and positive 2, it goes to 0 in the denominator. It's undefined. Alright, so on our number line, we can do anything but negative 2. We're going to negative infinity this way and positive infinity the other way, or negative infinity in the negative direction, positive infinity. So this will be from here, you should be able to figure out it's going to be infinity going in the negative direction to negative 2, open, union, negative 2 to infinity. Alright, that's our domain. Okay. Let me draw a line here to separate these parts. Okay. We also want to part E, list. Part E, list the X intercept. And this part you've got to show algebraically how this is done. So to find the X intercept, we set y equals 0, solve for x. To find the y intercept, set x equals 0, solve for y. So we would put 0 in here for f of x, and then we're going to put in there the x minus 3 over x plus 2. And then solve for, we've got to multiply out the denominator, which makes that go to 0. So technically, you could just set the numerator equal to 0. But if you had to, you could go with the xy intercept method and just stay consistent with that, and then be fine. And so we solve for that, we apply plus 3, and we get x equals to 3. And so you would just leave it like that. You would not put this particular one in a coordinate point. Alright, and then F, part F, lists the y-intercept. Make that better looking. There we go. So now we're going to set x equal to 0 and solve for y. So we're going to take our function again up here, and we're going to put 0 in for x. X minus 3 over x plus 2. So this will be f of 0, put a 0 in for x, 0 minus 3 over 0 plus 2, and we get negative 3 over 2 out. And so you would just write that as just 3 over 2. There'll be space for that. Okay, and so that's that particular problem. And so let's see, that was problem 4. And check something here real quick. Yeah, that was 4. Alright, we've got room here for problem 5. Determine algebraically whether the given function is even or odd. That function is even or odd. So if it says determine algebraically, you have to show it on the scratch paper. And we're given f of x is equal to, let's say, 2x squared plus 3, or plus, let's say, instead of 2x to the squared, let's say 2x to the 4th plus 3x squared. And so what we would have to do here is we would have to substitute in negative x. And so it's like we're cutting the x, cutting the x, cutting out the x, put parentheses. And so this is f of, and actually I want to do this. Plus 3. And then we're going to substitute negative x in. Negative x, negative x, negative x. And so negative x to the 4th, that's just 2, that's like saying 2 times negative x times negative x times negative x times negative x. So you get 2, that comes out to be 2x to the 4th. Plus, and this would be the same 3x squared. And so since it comes out to be the same, we would say that if we get negative x, f of negative x equals to x, this would be an even function. So in other words, we substitute negative x in, and you get the same thing you started with. That's an even function. Well, what would be considered an odd function? Well, if we had f of x equals to, let's say, x cubed plus x, and we substituted negative x in, so this would be negative x cubed plus, and then negative x, substitute those in, and we get negative x cubed minus x. So here we put negative x in, and we get a negative. All the signs change. This would be an odd function. And if you don't either get all the signs change or all the signs stay the same, then you would have neither. Okay, that is problem 5. Alright, so let's look at problem 6. And let's say we have this graph here. And let's say it comes up and down, and then it ends here and ends here. And we have these points, and let's say this is -1, -3, and this is +1, 2, and let's say this is 2, -1, and let's say this is 3, 4. Okay, and we want to know, find the absolute maximum and absolute minimum. Find absolute maximum and minimum, absolute minimum. Okay. So the way the question is going to be worded is the absolute maximum, and I won't write whole maximum out, of y equals to f of x is, and basically the max or min are, they're going to be the y values, right? Now normally the way we would answer it in class is the absolute maximum is, in this case, 3 at x equals to 4, but they're not, the test won't ask for this part. It'll only ask for the maximum or min. So try to figure out the absolute minimum. The minimum of y equals to f of x. So this y equals f of x, that should be a clue for you that you're just looking for the y values, which is a -3. Alright, and that would be at x equals -1, but they're not going to ask for that. Now how about the local maximum? What's that? Local maximum, that's where the curve, it comes up, reaches a peak, and then comes back down. So local maximum is different than absolute maximum. So local maximum there is, you should have said 2 at x equals 1. Alright, and then the local minimum, you should have said -1. Okay, so that's pretty straightforward. Alright, and that was question 6. Alright, question 7, determine algebraically whether the given function is. Alright, we did that, so you'll see another one like that. Question 7, solve the system of equations. Whoops, didn't want to do that. Where am I? Here we go. Solve the system of equations. And let's say that we have here y plus 3 equals 0, and we've got 3x plus 2y equals to 5. Alright, well what you want to do here is you can say, alright, if I were to subtract 3 from both sides, I could get y equals to -3, and then substitute that in. And so that would be negative 3, and for y, so that'd be 3x plus 2 times negative 3, and that'd be 3x minus 6 equals 5. So we would solve for x, and so we would add 6, and we get 3x equals 11. Divide by 3, and we get x equals 11 over 3. Well, we have y already. That was 3. Negative 3, rather. And so this would be 11 over 3, negative 3. And that's your answer. Okay, and that's all there is to that one. Okay. Now, let's say we have this graph, and let's say it goes like this, and let's say this is your x-axis and here's your y-axis, and let's say this is negative 2, 3, and let's say this is negative 1, 1, and this is positive 1, 1, and this is 2, negative 3, and so we want to know, determine the intervals which the function is increasing, decreasing, or constant. This is problem 8. Determine the intervals where the function is, we'll start with increasing. So you look to the y values to see where it's increasing. So it's increasing from the x, you're looking at the y values to see where it's increasing. So it's increasing up to where x is negative 2. So this way x is going on to infinity, so this is infinity negative in direction to negative 2. And they're always open. So it's increasing there, it's decreasing down here, constant, decreasing, but then here to where? To infinity. Okay, so that's increasing. Decreasing, interval where it's decreasing. Okay, stop, pause the tape, and try to figure this one out. And then start the tape and we'll see how you did. Okay, it's decreasing. Here we're going downward, right? So this would be from x is negative 2 to x is negative 1. So you look to see with the y values if you're increasing or decreasing, but your intervals are going to be in the x values. This is constant here. And then it decreases again. From x is 1 to x is 2. Okay. And then constant, our interval is constant. And that would be negative 1 to positive 1. Now, that's all we ask for that. Okay. Okay, next thing we want to do, this will be problem 9. is determine whether the graph below is that of a function by using the vertical line test. So let's say we have here this function, and we have our x and y axes here. So now notice this is a parabola, so it's not like they're going straight up. And so no matter where we apply the vertical line, it only intersects at one point. So this would be function. Yes, it is a function. All right, the domain. Now let's say this point is 2, 3. Our domain for any parabola, what is it? You should have said infinity to infinity. There's no x in the radical, there's no x in the denominator. Or there's no, in this case, there's no breaks, right? All you see is a graph. Okay, the range. Now, here, again, you want to draw a vertical line, but you go here and you're going to erase. And this is a definitive point, so this is what? You should have said 3. So therefore our range is closed at 3 to infinity. Alright, now let's say this point here is 4. Alright, and we want to know our intercepts. Now this you don't have to do algebraically because you just look at the graph. So in this case there would be no x intercept. Well, what about the y-intercept? That would be at x is 0, y is at 4. Okay. Any symmetry? Is there any symmetry about the x or y axes? Well, in order for there to be symmetry, you would have to take that graph, fold it in half at the origin, and it should be just one line. It should be like a mirror, same on the right side as on the left. Well, there's no symmetry about the y-axis, and there's no symmetry about the x-axis either. So in this case, there would be none, no symmetry around the x-axis, the y-axis, or the origin. Okay. Next one, problem 10. Let's say we have a problem such as x plus y equals to 3, and actually let's use 4, and y equals to x squared minus 2. Alright, well, since y is, and we want to solve using the substitution method. So basically, since y is already isolated, you can just substitute it into this y here. So this is x plus, and then where the y was, you want to put parentheses. X squared minus 2 equals to 4. And the reason why you want to do that is if this is a minus, you're going to have to distribute that minus. So we get x squared plus x minus 2, and then we're going to apply minus 4 to both sides because we want to get it equal to 0 because it's a quadratic. So that's x squared plus x minus 6 plus x minus 6 equals to 0. And what are we going to do now? You should have said we are going to factor. Put in our x's. What are the signs going to be? Because the C term is a minus, the signs are going to be opposite. Look at factors of 6, 1 and 6, 2 and 3. We want factors of 6 that will subtract to give us 1. So this will be 3 and 2, so we get x plus 3 equals 0 and x minus 2 equals 0. X equals to negative 3, x equals to positive 2. So we have our x values, but we have to find our y values. So we can substitute that back in to the first equation, since that would be easier one to work with. And so this would be negative 3 plus y equals to 4. And we would solve for y. Isolate the y. And we get y equals to 7. So this would be x is negative 3, y is 7. And then here for x equals to 2, put 2 in there for x, plus y equals to 4. Isolate the y, and we get y equals to 2. So this would be x is 2, y is 2. And so we have two solutions here. Okay, that's problem 10. And that's all of it. That is our review for the Unit 2 test. Please let me know if you have any questions. There are questions that you will be answering. Not all of these will have to be answered, but you will need to answer some questions for the review on this assignment. And have a great day.